Good morning, children. In today's class, we are going to continue problems in exercise 9.5 based on continuity. Let us recall. To check continuity at a particular point, x is equal to x naught. Left limit should exist, right limit should exist, function should be defined at that point, and all the three should be equal. Now we are going to analyze certain graphs, also some algebraic functions about this left, right and continuity. When you are looking at graph, if there is an open circle, let us recall that open circle expresses the function is not defined at that point. So if you have a graph like this and a graph like this, at this point there is a break, definitely it is not continuous. You may have a curve going like this, a curve going like this, where the left and right limit at that point are not equal. So check. Suppose some curves go like this. The left limit is not at all defined at a certain point. So we are able to check from the graph as well as from algebraic functions. If my question is x tends to a, put a minus, find the left limit, put a plus, find the right limit and find f of a. So the left right limits are equal, we say limit exists. The function value, say f of a is defined, it is called function value exists. Now all the three are equal, the left limit, the right limit and function value are equal. We can declare the function to be continuous at that particular point x is equal to x naught. Let us proceed into the problems. Question number 7. Let f of x 0 when x is below 0, x square when x is between 0 and 2 and 4 if x is greater than 2. Graph the function, show that f of x is continuous on 0, infinity. As I see, below 0, the function is 0. Function value starts from 0 only. So, below 0, the function is 0. When I come to x in between 0 and 2, it is x square. So, let us put some values for x in between 0 and 2. 0 equal to, so I can put x 0, f of x will be 0 square, that is also 0. In between 0 and 2, I can put 1. Here I put 1 square, it is 1. Between 0 and 2, say some more value, say 1.25, 1.5 and up to 2 I can substitute. When it is 1.25, 1.25 the whole square, that is 1.5625. When it is 1.5, 1.5 the whole square, which is 2.25. And when it is 2, 2 square becomes 4. Substituting these points in the graph, we get 0, 0. Here I mark it. 1, 1. 1.25 somewhere here up to 1.56. 1.5 exactly in the middle of 1 and 2 up to 2.25. And 2 it goes up to 4. As we join the points, we get a continuous curve from 0 to 2. After 2, see what is given in the diagram, 4. After 2, that is from 2 onwards, it is completely 4. So, it is a straight line parallel to x-axis which goes on and on. So, as I look at the diagram, from 0, it goes up to 2 for 4. And after that it is fully 4, same value, whatever be x value, f of x is going to be 4. So this is f of x curve. It goes from 0 to and so on. So it is a continuous curve. So this shows the graph of the given function. Let us check the left limit and right limit at 2. When I say left limit, substitute here. So if I put 2 square, my answer is 4. If I put right limit after 2, I have to substitute here, which is already 4. So the left limit is 4, the right limit is 4, and the function value x is equal to 2 falls in this interval, equal to 2. So substituting here, 2 square is 4, so f of 2 is 4. As I check, the left limit, the right limit, and the function value are equal, and so algebraically I can conclude it is a continuous function from 0 to infinity. Problem number 8. If f and g are continuous functions with f of 3, 5, limit x tends to 3, 2 times f of x minus g of x is 4, find g of 3. Given f of 3 is 5, that is the function value at x is equal to 3 is 5 for f. Also, f is continuous. When f is continuous, the function value and the limit value are equal. So I get limit x tends to 3, f of x is also 5. Now let us consider this case. Limit x tends to 3, twice f of x minus g of x is 4. As I split limit for the two functions, it is limit of the first function minus limit of the second function. Again, 2 can be retained outside the limit. 2 times limit x tends to 3 f of x minus limit x tends to 3 g of x is 4. But the limit value we have derived as 5 because f is continuous. Now I need to find this value. So bring this to the right, bring 4 to the left. 2 5s are 10, bring 4 to the left, it is minus 4. And so we get 6. Limit of g of x as x tending to 3 is 6. But my question says g is also continuous function. Continuity tells limit value and function value are equal. So limit x tends to 3 g of x 6 tells me g of 3 is also 6. And that is my answer. Question number 9. Find the points at which f is discontinuous. At which of these points f is continuous from the right, from the left, or neither? Sketch the graph of f. Given the function, it is defined in 3 different intervals. When x is below minus 1, it is 2x plus 1. When x is between minus 1 and 1, it is 3x. When x is above 1, it is 2x minus 1. Now, the problematic numbers are where and all the split is coming. Before minus 1, after minus 1. So, minus 1 we need to check. Also, before 1 and after 1. So, we need to check at 1 also. For the left limit at x is equal to minus 1. I have to put below minus 1. So, here 2x plus 1. As I substitute, it is 2 into minus 1 plus 1. As I simplify, minus 2 plus 1, that is minus 1. So, the left limit gives us minus 1. To proceed for right limit, I am more than minus 1. Minus 1 plus h. So, I will be in this interval. Here, we are given 3x. So, left limit of minus 1 substitute here. Right limit for minus 1 substitute here. 3 into minus 1 gives us minus 3. Left limit is minus 1 whereas right limit is minus 3. They are not equal. So we will declare f of x is not continuous at x is equal to minus 1. Now we need to check at x is equal to 1. The left limit 1 is here. To find left limit at x is equal to 1. 1 comes here as well as here. For left limit, check here. For right limit, check here. So when I am in left limit, 3x we need to substitute. So 3 into 1, which gives me 3. For right limit, substitute in 2x minus 1. As we substitute, it is 2 into 1 minus 1. 2 minus 1 is 1. So obviously they are not equal. Left limit is 3 whereas the right limit is 1, and so we declare limit does not exist and f of x is not continuous at x is equal to 1. Now we need to sketch the graph of it. To sketch the graph, the function below or equal to minus 1, it is 2x plus 1. Between minus 1 and 1, it is 3x. Above or equal to 1, it is 2x minus 1. As I substitute some values below minus 1, I can put minus 1, minus 2, minus 3. Substitute it here. What is my answer? 2 into minus 3 plus 1. That is minus 6 plus 1 minus 5. So when x is minus 3, my answer is minus 5. When I put minus 2, 2 into minus 2 plus 1. Minus 4 plus 1, my answer is minus 3. When x is minus 1, 2 into minus 1 plus 1, that is minus 2 plus 1, which gives rise to minus 1. Between minus 1 and 1, the function is 3x. Between minus 1 and 1, they are only decimals. One value easy is 0 and I can put 0.1, 0.2, 0.3, anything. Let us substitute 0.9. And to the left, minus 0.1, minus 0.2 up to minus 0.99999, I can substitute. So for easy sake, let us take minus 0.9 plus 0.9 and 0 inside this interval. As I substitute 3 into minus 0.9, minus 2.7. 3 into 0, 3 into 0.9 is 2.7. When it is above or equal to 1, that is 1, 2, 3 and so on, I can substitute. What is f of x? 2x minus 1. When I put 1, 2 into 1 minus 1, that is 1. When I put 2, 2 into 2 minus 1, that is 4 minus 1, which is 3. When I put 3, 2 into 3 minus 1, that is 6 minus 1, 5. As we try to plot this in the graph, minus 3 minus 5, minus 3 minus 5, minus 2 minus 3, minus 1 minus 1. So we can join it using the scale and it goes on and on. Up to minus 1 I can draw, so it will go down and down. The next idea, the second line, minus 1 to 1. We have marked minus 0.9, minus 2.7, minus 0.9, minus 2.7. 0, 0. 0.9 to 2.7. So as we join them using the scale. The next interval, x greater than or equal to 1. Here we have 1, 1, 2, 3, 3, 5. And as I join here, it is going more than or equal to 1. So the diagram will be from 1 but going on and on. Whereas here, it is between minus 1 to 1. So we will just put for 0.9 only. When it comes to the case of minus 1, it is an open circle. Thus we have sketched the graph for the given function. And from the graph we can very well notice there is discontinuity at the point -1 as well as at the point 1. The other places the curve goes on and on. See the lines? They go on and on. Only at 1, at -1, there is definitely a break. So it is discontinuous. Question number 9, subdivision 2. F of x is x minus 1 the whole cube when x is below 0. And when x is greater than or equal to 0, we get x plus 1 the whole cube. To check continuity, at 0 we need to check. When it is left limit below 0, substitute here 0 minus 1 the whole cube. 0 minus 1 the whole cube. My answer is minus 1 the whole cube, which is minus 1. When I come up to right limit, it is after 0, substitute here, which is 0 plus 1 the whole cube. 1 cube, my answer is plus 1. Left limit is minus 1, right limit is plus 1, and so they are not equal. We can immediately declare f of x is not continuous at x is equal to 0. To sketch the graph of it, let us say some easy values. I want below 0. I can take -1, -2, -3. As I substitute, -1, the whole cube is -2 the whole cube, -1, -2. The whole cube is -8. If I put -2, -1, the whole cube is -27. If I put -3, it is -3, -1, the whole cube is -64. Similarly, we can substitute for the next interval where x is more than or equal to 0. So equal to 0 tells me I can start from 0. Say the value 0, 1, 2, 3. As I substitute in the function which is x plus 1 the whole cube. When I put 0, 0 plus 1 the whole cube, that is 1 cube, which is 1. When I put 2, 2 plus 1, 3, the whole cube is 27. When I put 1, 1 plus 1, 2, the whole cube is 8. When I put 3, 3 plus 1, 4, the whole cube is 64. As we plot the points, -1, -8, -1, -8. We are taking because f of x values are higher. Take y-axis scale to be 10, 20, 30, so 10 units per centimeter. X-axis values are less only, so we can obviously take 1, 2, 3, this side -1, -2, -3. As we try to plot, -1, -8 here, -2, -27, 20 to 30 somewhere here. As I try to join the curve, can I touch 0? No, because my value is less than 0. I cannot put 0 at this point. It is below 0. And the curve can go on and on. The other limit, x greater than or equal to 0. At 0, the value is 1. So this is 10 units, 1 will be somewhere here. When it is 1, the value is 8. 1, 8. 2, 27. 2, 20 to 30 somewhere here. So against 2, 27. As I join these points, I get a curve like this. And the curve will go on and on. So it is continuous from this point, it is continuous up to this point. But at 0, the left limit and right limit are different. So I will say it is not equal to and so we can declare f of x is not continuous. Fifteenth problem, A part, state how continuity is destroyed at x is equal to x naught. Graph is given. We need to check whether it is continuous or not. As I look at the curve, here there is an open circle which tells us the function is not defined here. Also, the left of x naught, here I have, so this value I call left limit. To the left of x naught we are here. To the right of x naught, when it approaches from right, so this is right side I say, and this is left side I say. As x approaches x naught from the right, here we have the limit. So the corresponding value I call right limit. So the left and right limit are not equal. So continuity is destroyed at x is equal to x naught because the left limit is not equal to the right limit. So we will say f of x naught minus is not equal to f of x naught plus. Therefore, discontinuous at x is equal to x naught. B part, here we are given the curve and there is an open circle here. If I look at x naught, as it approaches x, as x approaches x naught from the left, the corresponding value we have left limit. As x approaches x naught from the right, now also I have the same as the right limit. And I say both are equal. Left limit is equal to right limit. But there is an open circle which tells the function is not defined. So continuity is destroyed at x is equal to x naught because function is not defined at x naught. So whenever there is an open circle, remember the function is not defined. C part, here again we are given a curve like this. This is x is equal to x naught. As I approach x naught from the left, we have the left limit here, which is minus infinity. And as x approaches from the right, we have the right limit here, which is plus infinity. So we have the right limit here, whereas the left limit here. And obviously, left limit is not equal to right limit. So we get right limit as plus infinity and left limit as minus infinity. And they are not equal, so we will immediately declare continuity at x is equal to x naught is destroyed because limit does not exist. D part. Given a curve like this, as I look at x naught, as x approaches x naught from the left, this is the value of left limit. As x approaches x naught from the right, this is the value for right limit. So obviously, left limit is not equal to right limit at the point x is equal to x naught. So continuity is destroyed because left limit is not equal to right limit in this case.